Just as I was preparing this update for the Wan Video Workflow, version 2.2 was released. The development of AI in the video generation field is truly insane. However, in this episode, we'll still focus on the many new ways to use version 2.1. Next time, we'll talk about version 2.2. Let's first look at two tables. The first table shows the ecosystem of Wan Video. I have organized all the general features and models related to Wan Video. Models include main models, low-step models, functional models, and control models. Each feature or model has a link. Another table lists all the sub-workflows in my Wan Video Workflow, organized by video generation method and node version. First, let's look at the hotly discussed long video generation methods in the community recently. The methods used for these three videos are Skyreel V2DF, VACE, and Inpaint, respectively. The video is divided into 3 segments, with no issues in the transitions between them. However, the video's color gets darker with each segment. This is caused by using low-step Lora. These low-step Lora models all include a certain degree of image effect enhancement, which gets cumulatively enhanced. Currently, this issue cannot be perfectly resolved. We can't just abandon low-step Lora, can we? Or add color matching. Let's first look at the looping process of generating video from multi-frame starting frames. In each loop, the first and most critical step is to take several frames from the end of the initial video, i.e., the previous segment, as the starting frames for the current segment. This ensures the maximum natural transition between the two video segments. Additionally, you can set corresponding parameters for each sampling loop, such as seed, positive prompt, and even CFG and scheduler. After sampling, extract the useful part from the images generated in the current loop. That is, the images excluding the overlapping parts. Add these useful images to the end of the intermediate video, update the initial video, and in the current loop. As you can see, the initial video is updated at the start of each loop, becoming the intermediate video from the end of the previous loop. When a loop count reaches its limit, the loop ends and the final video is output. The number of loops will become an integer list of loop numbers. All numbers in the list will be loaded in sequence and used as indices in the parameter loop lists. Let's first look at the 3 most critical parameters in the workflow. The first is the total number of frames, or the number of frames to add. The second is frames per loop. Skyreel V2 supports 97 frames. The Wan series is 81 frames. The third is the number of overlapping frames, which will serve as the starting frames for video generation. There's a switch here that specifies how the preceding video is obtained, whether it's loaded or generated. If generated, the group numbered first is used for generation. When generating the preceding video, there's a recommended calculation formula for controlling video length with the total number of frames. The number of frames generated in the first segment, which is the frames per loop, plus the frames generated in several subsequent loops, equals the total number of frames. The number of useful frames generated in each subsequent loop is the frames per loop minus the overlapping frames. This ensures that the number of frames generated in each loop reaches the maximum number of frames supported by the model, which is the frames per loop. For 271 frames, besides the preceding video generation segment, exactly 2 more looped video segments will be generated. If the preceding video is loaded, then total frame control becomes add frames control. In this case, the number of frames in the preceding video does not need to be considered. The added 271 frames will require 4 loop segments to generate. By calculation, the number of frames generated in the last loop is 10, which may not yield good results. According to the suggestion, either remove these 10 frames or complete the number of frames for this loop. For complete loops would be 348 frames. Let's look at the model settings. I have a note here. Low-step Lora models cause enhancement effects to accumulate.
You can either abandon low-step Lora or add color matching, but I don't think either is the best method. This awaits future solutions.
Also, please pay attention to the loop parameters, which means setting different parameters for each loop. For example, here I've added different positive prompts for 2 loop segments. You can also add a third one. If the number of elements in the provided parameters loop list does not match the number of loops, insufficient elements will take the last one, and excess elements will be ignored. In addition to this, I have also added float and integer parameters as alternatives. You can control CFG and steps. You can even control different schedulers. Video generation is divided into 2 parts. We already know that if there is only one start frame or prompts without a preceding video, the first step can generate it. Text-to-video and first frame-to-video are supported here. After the first step is completed, we move to the loop generation segment. Here, generating the preceding video is used by default. The loop count parameter is transformed into a loop index list, used to control the number of loop generations. Here, I'm using the for each list node from the Inspire Pack custom nodes. In the current loop, besides loading the intermediate video, it can also load the element from the list, which are our index numbers. Based on the index number, we can then load the various loop parameter lists. For example, the integer and float parameters here, and also the positive prompt parameters. Of course, you can also load the scheduler. There's also a more complex calculation for the number of frames in the current loop here. Regular loops follow the frames per loop, while the last loop will ensure it uses the remaining number of frames. Here, you can choose to use the same positive prompt or a loop parameter list. For the seed number, you can choose to use a fixed value, or increment, or decrement. Disconnecting it means random seed numbers. After generation is complete, it will automatically get the images with overlapping frames removed. The node provided by KJ is used here with a starting index of -1, meaning it counts backward from the last position. Then, add it to the intermediate video and update the intermediate assignment for the loop. Once the loop list is completed, the loop ends and the final video is output. What you're seeing now is a comparative test of low-step Lora. The exact same generation environment and parameters were used. The first one, without Lora, took 548 seconds. LightX2v used 4 steps and took 102 seconds. FusionX used 8 steps and took 196 seconds, and so on. Comparing them, LightX2v is the fastest, but at 8 steps, it should be around 200 seconds, similar to the others. FusionX produced the best results, followed by LightX2v and FastWan. Vid has a relatively poor understanding of human motion, which deducts quite a few points. Pusa is a very strange Lora. According to the official configuration, using 5 or 10 steps doesn't yield good results. I tried using it with LightX2v, and the results felt acceptable. But its understanding of human motion is also quite mediocre, so I've given up on using it. Next, let's look at reference to video generation, continuing the achievements of the previous version. Currently, it supports 3 reference images, 2 for the subject and 1 for the background. Phantom supports 4 images, requiring an additional set of pre-processing nodes to be added manually. Pre-processing includes background removal, cropping by mask, and then matching the output resolution. Besides single image, there are 3 other ways to use it. These include batch, concadence, and composite. We can refine this composite image and use it as the first frame. There's also a color map, which can be used as a target mask for Multitalk or Infinite Talk. Besides the first frame, there's also the concept of a first batch. This was introduced by Skyreel A2, where connecting the first batch of images to the first frame can also yield results similar to reference images. For Skyreel A2, the first batch includes one first reference image and for each of the second and third reference images. The currently provided sub-workflows include the shared Skyreel A2 and MAGREF workflows, as well as VACE, Phantom, and the newly released stand-in. The VACE workflow has added a switch for using batch or concatence. You can also choose whether to use first frame control. Choose to use the first frame or first batch. For Skyreel A2 and MAGREF, since they are based on image-to-model generation, clip vision is used. In addition to the reference batch and concatence switch and the first frame/first batch switch, there's an additional latence parameter. Because the dimensions must be consistent with the output resolution, batch referencing must be used for encoding here. What exactly is the purpose of this additional option? There will be a comparison video later. Phantom uses a dedicated node and supports up to 4 reference images. But because it's based on text-to-video, it also has a very powerful feature. It can connect to VACE. This opens up new possibilities, using either Phantom or VACE to process different reference images. You can even combine VACE with first frame-to-video generation. Let's look at a comparative test of VACE's reference-to-video generation. I've listed the reference image methods below the corresponding videos. The first one used batch reference. You can see the images included in the batch in the bottom left corner. This one not only used batch reference, but also a composite image as the first frame. You can also see the composite first frame image in the bottom left corner. If only batch reference images are used, the fidelity of the subject and background in the generated video is significantly worse. Adding a composite first frame results in very high fidelity. It can be said that first frame to video is actually the most powerful reference to video method. So, the question arises, since first frame to video can already achieve very good result, why still use reference to video? Firstly, if the reference image and the composite first frame use the same reference, it can further increase detail. Secondly, the reference image used with the composite first frame should be used to add new elements that appear outside of the elements present in the composite first frame. For example, in this case, the character is given specific sunglasses. However, it's worth noting that VACE doesn't always successfully reproduce the sunglasses from the reference image. Furthermore, in this example, besides the first frame and reference image, a first frame repainting function has been added. This is an advanced application of VACE. Personally, I think for VACE, using a concatence reference provides higher fidelity than a batch reference. The concatence method utilizes pixel space more efficiently. The optimal choice is to use both collage reference and a composite first frame together. The rightmost column used the first batch as the first frame. For VACE, in the first batch, there's one of each of the 3 reference images, which is equivalent to a batch reference. This method is quite amazing. In terms of results, besides this penguin, the fidelity of the female knight and background is even better than with batch or concatence references. However, there are still some issues with scene transitions. This approach is quite interesting. This set is a comparison of Skyreel A2 using different reference image methods. After the recent update to the Wan Video Wrapper, Skyreel A2 does not generate correct results when using only reference images or batch latents. In the previous version, it could still generate correctly. Fortunately, I kept a record from before. While it won't change the ultimate recommended usage, I feel it's somewhat regrettable to be missing these 5 possibilities. Therefore, when using Skyreel A2 now, you must use either the composite first frame or the first batch as the start frame. However, using the composite first frame still yields the highest fidelity. Using only the first batch, the result was quite striking. The female knight in digital painting style actually turned into a real person. This drawback can be improved by adding batch latent. The fidelity is highest, perfectly preserving the 3 different image styles from the 3 reference images. This is surprising. Could this be the strongest reference to video solution? MAGREF and Skyreel A2 are very similar. They even use the same workflow. As long as a composite first frame is used, the results won't be bad. What's rather strange is that an extra sword and a penguin doll appeared in the image. Perhaps this issue needs to be resolved by retrying, or maybe MAGREF used a repeated reference. Using only the first batch seemed to yield better fidelity than Skyreel A2. After adding the starting frame, the penguin looked less like itself. Using both the first batch and batch latent simultaneously can achieve the highest fidelity. Between MAGREF and Skyreel A2, I would choose the latter. Regarding Phantom, I have listed all possibilities except using the VACE starting frame feature. After all, based on previous conclusions, using a starting frame is definitely the first choice. Phantom is currently a model that can achieve excellent fidelity without providing a starting frame. First, let's look at this group using 1, 2, and 3 reference images respectively. Phantom's low fidelity for background reference images has always been a major problem. Adding a background reference image can even weaken the subject's fidelity. I tried adding a VACE reference to see if it could address this issue. For example, in this scenario, Phantom is used to reference the female knight and the penguin, while VACE references the background. Although the background features were not fully restored, it is still acceptable overall. Next, it's a matter of permutations and combinations to see how to use them to get better results. I found that using both Phantom and VACE for subject referencing can achieve better detail and style fidelity, which is especially evident in the penguin. Adding VACE's background reference on top of this does not weaken the results. It should be noted that, for comparison purposes, VACE only used batch references and not concordance references. Using the latter might yield better results. In the Wan video wrapper, VACE can be used as a module, making it very convenient to combine Phantom and VACE. This opens up endless possibilities for reference to video generation, and more importantly, allows for the continued addition of VACE's powerful video control features. So, how can this be achieved in a native environment? We just need to add a VACE node before the Phantom node. And fortunately, the community has just released a merged main model of VACE and Phantom, making this possible. The author was very thoughtful and listed detailed usage guidelines and workflows in the description. Anyone interested can take a look. There's even a version that merges the low-step COSVID solution. Many thanks indeed. Reference to video actually has an even more advanced application, which is what we commonly refer to as face swapping. For example, if we want to replace the face in this video with another face, how should we do it? We can use VACE, Phantom, Stand-in, or Skyreel A2 MAGREF for video-to-video generation. We need to prepare a reference image of a face. For example, if we want to swap it with this male warrior's face, we need the original video, as well as a face mask video. For VACE, we also need to prepare a repainting control video. How should we obtain these 2 auxiliary videos? In my auto-masking module workflow, Florence2 and Sam2 can be used to obtain face masks. This process originates from KJ. Florence's role is identification, and Sam's role is cropping. The generated results also need processing, such as dilating and blurring before they can be used. In my control video module workflow, methods for generating VACE repainting control videos are provided. By loading the original video and the corresponding face mask video, it can be completed automatically. Let's look at the VACE solution. First, it's a video repainting process. Adding a reference image completes the task. Original video sampling is achieved through this encoding node. Repainting is done by lowering the denoise value. Please note, the higher the denoise value, the more it resembles the reference image, but it will lose the facial expressions and mouth movements of the original character. The approach for the native workflow is the same. But please note, an error occurred when I performed encoding sampling on the original video. I have listed the information in the comments. Therefore, the denoise value must be 1, making it difficult for face swapping to match the original character's expressions and mouth movements. Phantom is a text-to-video model, so it can also be used for face swapping. Let's look at the results. Because my prompt still specifies female knight, the face swapping result is not ideal, but the operation process is correct. Only one reference image is used here. The sampling encoding of the original video has been added. Because video repainting changes all parts of the image, the range needs to be controlled. However, in the Wan video wrapper, adding a mask during video encoding does not yield ideal results. So I added a compositing process using a mask to place the face swapped area over the original video. Of course, this part of the task is best completed in post-production compositing software. After all, video repainting adds many details, such as dynamic hair details, which can be preserved. The usage of stand-in is very similar, so I won't elaborate on it here. Let's look at the comparison video. Phantom's face swapping results seem to be quite different from the reference image. The two examples of native VACE couldn't reduce denoise, so the results were very unsatisfactory. If you want to be identical to the reference image, you still have to use stand-in.
The other two, unique 3D and flexi cubes, could not be generated locally because of my VRAM limitation. The other two, unique 3D and flexi cubes, could not be generated locally because of my VRAM limitation.
The set of videos you are seeing now is a comparative test of Multitalk and Infinite Talk. These two modular models are very similar, both applicable to text-to-video and image-to-video models. KJ even made them share nodes in the Wan video wrapper. They both support fun control and VACE control for text-to-video, with depth control being used here. But I found they conflicts with dilated control net. They support first frame to video, VACE first frame to video, and complex VACE control. Both support single or multiple target subject speaking. After adding a context window, it supports long audio-driven generation. Infinite Talk handles window switching transitions better than Multitalk. When using the image-to-video model, in addition to context options, you can also utilize its own long video control node, resulting in a very natural transition. Open the first frame to video workflow and focus on Multitalk, which shares the workflow with Infinite Talk. Multitalk supports up to 4 voices, controlled using target masks. The RGBA 4 channels of the target mask control the range of the first to 4th targets respectively. Here I used the red and green channels, representing the female knight and the penguin respectively. When using an image-to-video model, there's only one method, first frame to video. But as long as the main model is switched to a text-to-video model, Multitalk can be used with VACE. Besides first frame to video, there's so much more we can do. Here I have 3 modes to switch between: first frame, Inpaint first frame, and Outpaint first frame. Of course, you can also continue to add control videos. 4 VACE first frame repainting control methods. Those interested can watch my first one video tutorial. Regarding the use of VACE, a new keyframes to video solution specifically for long videos has been added to the workflow. When VACE generates long videos, it's difficult to control during context window switching. It can even switch to a different scene, as if becoming text to video. This solution can now effectively address this issue. As you can see, After processing with the VACE start-to-end frame node, this batch of images and masks was generated. In this example, I also had VACE perform inpainting on the first frame. Theoretically, you can make VACE do anything on any frame, including repainting, video control, using specified images, etc. Currently, the video has 177 frames, requiring 3 context windows to complete. We need to replace the starting frame of each window with the image we need. According to the notes, when the frame count is greater than 81, connect the image and mask slots here. When the frame count is greater than 162, connect the image and mask slots here. This way, the first frame of each window, specifically images numbered 81 or 162, i.e., the 82nd or 163rd image, can be replaced with our specified image. In this example, since it's only for Multitalk or Infinite Talk and the character barely moves, the same first frame is used. You can also insert a series of custom images here, just like specifying keyframes, allowing VACE to handle the transitions and connections between them, thereby creating a long video generated from a series of videos linked by start and end frames. This is off topic, but in the next update, I will take this solution out separately as another workflow for long videos. Please pay attention to this detail. The masks of these 2 keyframes specify the repainting range, which is because I want the non-repainted parts of the image to remain unchanged. However, the first frame mask generated by the VACE start-to-end frame node is completely black. This is likely because when the start frame slot is occupied, the first frame mask automatically turns black. However, it doesn't seem to affect the result much, so we'll ignore this issue for now. The same applies to outpainting. This solution ensures that VACE still generates video based on the starting frame when switching windows and does not arbitrarily generate text-to-video. Then, for first frame-to-video generation, it's even easier to understand. In this example, I made the first frame reappear at the 82nd and 163rd images.
The other 2 unique 3D and flexi cubes could not be generated locally because of my VRAM limitation. The other 2 unique 3D and flexi cubes could not be generated locally because of my VRAM limitation.
In this video, you can see the lip syncing I achieved using Fantasy Talking, Multitalk, and Infinite Talk, respectively. You can synchronize the character's lip movements with audio based on the original video. This solution is somewhat similar to face swapping, also achieved through video repainting. In addition to the text-to-video model, it can also be based on the image-to-video model, which is illustrated by the examples in the green box on the right. When using the image-to-video model, the character's appearance remains unchanged. The higher the denoise value, the larger the lip movement, but the less it follows the original character's head movement. When using the text-to-video model, the higher the denoise value, the more the character's facial appearance changes, but the lip movement range is larger. Different models require different denoise values. Overall, Multitalk and Infinite Talk are better at balancing facial preservation and lip syncing. The repainting results, based on the image-to-video model, are better. In the video-to-video workflow, find the Fantasy Talking and Multitalk sub-workflows. Here is the necessary original video sampling and encoding processes for video repainting. For text-to-video model workflow, you need to provide the original video and a face mask video to use it. Manual compositing is added here to put the facial range onto the original video. For image-to-video model workflow, you only need to provide the original video. What you're seeing now is the newly launched Fantasy Portrait. Everyone should be familiar with Live Portrait. Fantasy Portrait is its advanced version specifically for video generation, used for expression and motion transfer. However, the Wan Video Wrapper currently only supports a single target.
The other 2 unique 3D and flexi cubes could not be generated locally because of my VRAM limitation. The other 2 unique 3D and flexi cubes could not be generated locally because of my VRAM limitation.
Not only that, it can also be used in conjunction with Multitalk or Infinite Talk. Expression and motion transfer, along with lip syncing, are handled simultaneously. This is truly impressive. The expressions and movements in the example are very exaggerated, but Fantasy Portrait, Multitalk, and Infinite Talk still perfectly completed their tasks. As you can see, lip syncing is added on top of the expressions, especially the mouth movements. Next, let's look at the workflow. This is the expression-driven video. A first frame. The node settings are quite intuitive. This Add Fantasy Portrait node can be added on top of the existing image embed. Currently, it's added on top of the first frame's clip vision. Load the Fantasy Portrait module model, and the setup is complete. If you want to add Multitalk, you just need to add another Multi-Infinite Talk module model and the corresponding Multitalk embed node group. There's also a facial landmark point visualization here. As for video-to-video or video repainting, we are actually quite familiar with it. The usual approach is to use a text-to-video model combined with an empty image embed and original video encoding sampling. Simply reducing the denoise value is enough. Actually, image-to-video models can also be used for video repainting. The difference lies in loading the first frame of the original video as the image embed. Let's watch the video. The top left is the original video. The bottom group is video repainting based on a text-to-video model, with different denoise values yielding different results. A denoise of 0.65 produced good results. The top group is video repainting based on an image-to-video model. At a denoise of 0.45, the difference is not very noticeable. At a value of 0.65, subtle changes in the character's movements can be observed. At a value of 0.85, the movements already show clear differences. It feels like finding an intermediate transitional result between the original video and a completely first frame generated video. In fact, when the denoise value is 1.0, it becomes a complete first frame generated video. This is also a good method for video repainting. How do we remove the ballerina from the video? Let's compare the results of VACE repainting and MiniMax remover. When using a bounding box mask, VACE repainting still yields better results. After all, you can also specify a reference image to show what it should look like after removal. Interestingly, when using a human contour mask, VACE surprisingly failed to erase it. Instead, it drew another dancer based on the contour, treating it as motion contour video control. Let's look at their workflows. First, for the mask, we still obtain it using the auto-masking workflow. For the mask required by MiniMax remover, we use character as the keyword. A bounding box mask is more suitable for VACE repainting removal. After generating the mask video, the next step is to generate a VACE repainting video in the control video workflow. Moving to the video-to-video workflow, load in the original video, mask video, and VACE repainting video. Switch to the MiniMax remover subworkflow. It works with just the original video and mask video. VACE's removal solution requires a reference image to be provided. This image is the result of my repainting with SDXL, and the ballerina has already been removed. To obtain more effective pixels, crop according to the first frame bounding box mask. In other words, the removal function is achieved through VACE's repainting combined with a reference image. Uni3C is a solution I highly recommend, but unfortunately, it has not been fully integrated into the Wan video wrapper. I now feel that it won't be, nor is it necessary, in the future. Let's first review Uni3C, which is divided into two parts. The first part is the PCD controller. It generates a point cloud from an image, then sets up camera motion and renders it into a sequence to serve as the camera's control video. The part already implemented in the Wan video wrapper uses this control video to control the camera. It doesn't generate point clouds or set camera motion. This is actually a clever approach, as it's not mandated to use a same reference image to achieve matching camera motion. You can fully obtain camera motion from any video. This step is somewhat similar to camera tracking in 3D production. Since no reference image is needed, this part of camera control should ideally work with text-to-video models. However, perhaps due to internal algorithm issues, it's currently only usable with image-to-video models. Really's dance is the second part, used to drive character dynamics based on skeletal animation in 3D space. However, it requires videos generated by SMPLX and Hammer to function. Really's dance has already released its code. The official documentation further specifies the sources for control videos, namely SMPLX, Hammer, and DWPose. They also need to be installed separately. In the Wan Video Wrapper, although the Really's dance code has been integrated, without the SMPLX and Hammer tools, it's essentially useless. There's indeed no need to integrate the SMPL and Hammer tools into the Wan Video Wrapper. So, it's best to simply treat Uni3C as the most flexible camera control tool for image-to-video. Here, I'll introduce a method for creating custom camera control videos. This camera video gen custom node is specifically designed for those unfamiliar with 3D production software. Unfortunately, it currently only has a Chinese interface. Download and run it, then go to this web interface. First, set the animation frame rate and resolution. It's best for character animations to remain still. Because there's no interference from moving objects, there won't be offsets or disturbances during camera tracking or control. The number of camera motion segments refers to how many camera motion properties you want to control. For example, I'm controlling 3 properties. Click Update. 1 is elevation, 1 is x-axis pan, and 1 is azimuth. The start frame is 0 and the end frame is 81. Set the start and end values for each. Click Play Preview to check the animation. Adjust the x-axis pan value. This is how a camera animation is produced. Export as a PNG sequence. The sequence is in this compressed package. In the first frame-to-video workflow, I added a Uni-C switch. One is a fixed camera, the other is a custom camera. You can use it by linking it to Uni3C embed. A fixed camera is essentially several identical images. A moving camera, however, needs to load control video files, such as the sequence we just generated. Let's look at the camera control video and the final generated video. The camera control results are quite good. However, the character's movements are not ideal. It would be even better if there was a way to control the 3D space skeleton. KJ has already added the Really's dance node, but it's difficult for us to obtain SMPL and Hammer videos. Let's see what they look like. This is an SMPL video, which applies DWPose animation to a spatial skeleton. This is a Hammer video, focusing only on hand movements. Is there no other way for us to obtain 3D skeleton? But we also have a good news, the MTV Crafter tool, which continues Uni3C's approach. The author compared the impact of 2D skeletal animation and 4D skeletons on video generation. A 4D skeleton is actually a 3D skeletal animation. This solution is divided into 2 parts, skeleton generation and skeleton-driven animation. This means it can achieve both the Really's dance driving part and also includes SMPL skeleton creation. And KJ has already started testing its 2 models. I believe we'll be able to use it in the near future. In a new version, I added a native ATI trajectory workflow. This track-to-video node is the native node for processing ATI. For the trajectory string list, I provide 2 methods. The first is the string input. You just copy the trajectory string list into it. The other is this node I provide, which can load a JSON file containing a list of strings. So, How do you get the ATI trajectory? There are also two ways. The first is KJ's spline editor. The other is the tool I'm introducing today. In my automatic motion workflow, I've included a method for generating multi-trajectories using KJ's spline editor. One editor can only generate one trajectory, so 6 trajectories require 6 editors, which is a bit more troublesome. After merging them, save them as a JSON file. This trajectory generation tool is likely provided by ComfyUI officially, based on the tool provided by the ATI author, and is very simple to use. First, set the canvas size. Import an image and draw the trajectory on the canvas. Click Copy JSON. Go back to the workflow and paste it into the string input panel. Alternatively, create a new text file, paste it in, and save it as JSON format. When you need to load it, copy the file path and remove the quotation marks at both ends. This will also work. I'll focus on introducing several new features in the new version of the Wan Video Wrapper. Set Lora and Set Block Swap allow adjustments after the main model is loaded, without having to reload the main model. Set Block Swap is easy to understand. So what's the difference between preloaded Lora and Set Lora? Both can be used individually or mixed together. Place Lora models that must be used and have fixed strength in the preload position, and place those that need testing in the Set Lora position. There's only one difference. Preloaded Lora can be merged with the main model, while Set Lora cannot, resulting in slight differences. From this video, it can be seen that after Lora is merged with the main model, there are slight differences in detail, but not enough to affect the overall quality. However, I only used a low-step Lora, so it might not be universally applicable. Theoretically, the merged result should be better. Radial attention is another attention method. It is slightly faster than sparse attention. I personally believe the generated results are also better, so in my workflow, radial sage attention is set as the default attention method. If you want to switch back to sparse sage attention, you need to change it to sage attention in the model loader and bypass the set radial attention node. Let's look at the comparison of videos generated by both. From my personal perspective, I prefer the radial sage attention version. It appears more realistic. Sparse sage attention has slightly stronger contrast, but this is definitely a matter of personal preference. However, note that radial attention has certain resolution limitations. There's a note here with suggested resolutions. Simply put, video resolution can no longer be generated at a ratio close to 16:9 or at the resolution recommended by the video model. Here are the radial attention resolutions that are closest to the video model's recommended resolutions. Our most commonly used 480 by 832 became 512 by 832. If the block size is increased to 128, the generation speed is faster, but the closest resolution becomes less ideal. So, if you're more sensitive to resolution, then choose the traditional sparse sage attention. Next, let's look at free init. First, the drawback. This iter count means a video segment will be generated repeatedly that many times. Here's a brief introduction. Its core is stabilization technology. It can achieve better movement consistency. When used with current low-step models, it only takes the time of one previous generation, but iterates 3 times, yielding better results. KJ also shared his method of separating the first step from the second and third steps, which allows for obtaining both the results before and after using free init simultaneously. For this set of videos, I tested with 1.3B and 14B text-to-video models, as well as an image-to-video model combined with low-step Lora. It's indeed evident that after enabling free init, the fluidity and consistency of character movements significantly improved. body intersections, deformations, frame jumps, and unrealistic physics were all improved. This is truly a heavyweight feature. The famous NAG, an enhanced version of negative prompting, has also arrived in the Wan video ecosystem. This has been widely used in the field of image generation. When generating video, you can use NAG through this apply NAG node. Connect the embedded text generated by the original positive/negative prompts and the dedicated NAG embedded text, respectively. There's a simple explanation in the comments. The default settings are suitable for video generation. To use the native text encoder, you need two embedded text bridge nodes. One connects to the positive/negative prompt encoder, and the other connects only to the NAG text encoder. Then connect them to the apply NAG node. Additionally, KJ also created a cache text encoder. It can completely unload the model from VRAM and RAM after encoding. This is quite useful for those with low VRAM and RAM. Because my solution runs the text encoding model on the second GPU, I did not use this set of nodes. As for this enhanced tool that uses Quinn's large model for video prompts, my test showed it wasn't ideal with a lot of garbled text and strange languages. So, I didn't include it in my workflow. With the update of my Wan Video Workflow, my Jake upgrade custom nodes have also reached version 2.0.0, with a significant update being the replacement of group nodes with subgraphs. After multiple iterations, subgraphs were officially released in front-end version 1.24.0. Although the current subgraphs still have some flaws, I think they are usable, so I've replaced group nodes with them in my workflow. I have also retained the group node workflows, but they can only be used in front-end versions prior to 1.23.4. When using subgraphs, you first need to understand two concepts. The first is cloning, the second is copying. First, let's look at this group, which belongs to a clone version. In the node search menu, you can see 4 strangely encoded nodes. Each code represents a subgraph clone, and each clone contains several nodes. By node ID, find the corresponding subgraph nodes. IDs 1, 2, 3 are one group of cloned subgraphs, and IDs 4, 5, 6 are another group of cloned subgraphs. The two groups are different copies. Subgraphs belonging to the same clone share editing history, meaning that after we edit one subgraph, other clone nodes will update synchronously. For example, if we add 2 outputs, subgraphs belonging to the same clone will also add them synchronously. This set of copies remains unchanged. To clone, press the Alt key and left mouse button, then drag the mouse. A subgraph node was added to the first clone. Alternatively, right-clicking on the node and selecting Clone will also yield the same result. If you want to get a copy, meaning one that doesn't share editing history, then you need to use the Ctrl-C and Ctrl-V method. Copying and pasting between different workflows will yield copy. However, to create a copy within the same workflow, you need to save the workflow first and then refresh. I added an input, and only this subgraph changed. The other copies did not. Subgraphs have a flaw regarding string inputs. You can see these 2 sets of clones. Sometimes the string text and hint text of the clones don't display. I have named the 2 input ports positive and negative respectively. However, the hint text still shows the node's original name. Additionally, string inputs and clone subgraphs will be treated as editing history, affecting all clones. This is not what we need. What we need is to allow different parameter values for clones. Therefore, in the current version, if you need to use subgraphs containing string parameters, e.g., prompt-related subgraphs, within a workflow, it's best to use copies to avoid mutual interference. As you know, version 2.2 of Wan Video requires two sampling passes, high noise and low noise. We can simplify these sampling nodes into a subgraph, exposing only the necessary parameters. Let's open it and take a look. Inside are two advanced sampling nodes. The first one adds noise and returns with the leftover noise. The second one does not add noise and does not return with the leftover noise. Through subgraphs, we can control identical parameters using the same input port, hide parameters that don't need controlling, and set default values for parameters. In comparison, parameters in group nodes do not have default values. Hiding parameters in group nodes after front-end version 1.16.0 also leads to disorganized parameter ordering. It's necessary to force assignment by connecting, for example, these two sets of enable and disable parameters. Most importantly, group nodes cannot be re-edited. They must first be converted into nodes, edited, and then another group node created. This is a major reason they were replaced by subgraphs. When I replaced group nodes with subgraphs in my old workflow, I found an issue. Many connections between nodes disappeared, and reroute nodes became incorrect data types. This is a very strange phenomenon, but it's definitely related to subgraphs. At this point, you need to reconnect nodes, delete disconnected or incorrectly typed reroute nodes, and rebuild them. The repair process requires great care, as you never know where these issues might arise. This workflow is quite typical. I was fixing the CRITA API workflow, and there were particularly many errors. It's recommended to save the workflow and refresh after fixing some errors to see if the changes are successful. In the video, a connection to an image reroute node was broken, which I didn't notice. Fortunately, this is a one-time task. Additionally, I found that when replacing, copying old nodes into a workflow that only contains the replacement subgraph nodes can reduce the chance of errors. Please note that if you are performing a replacement update based on an old workflow, or if copying old nodes included group nodes, you need to erase the traces of group nodes from the workflow's JSON file. Open the workflow JSON file, search for the keyword group nodes, find a matching brace, and delete the value of group nodes, which is the content between those braces. The group nodes itself can be deleted or kept. Refresh ComfyUI and reopen the file. There will be no group nodes, only subgraphs. Because after front-end version 1.24.0, the group node editor can only be displayed by right-clicking on a group node. This means that even if you delete other group nodes through the editor, the current group node cannot be deleted, and at least one group node will remain in the workflow. Subgraphs have another annoying problem. These two nodes belong to the same clone. Let's run it once. Everything is normal. When I bypass this group and run again, the node above will show an error message, meaning it has no output. This is because this node, like its clone, has also been bypassed simultaneously. Clone nodes actually share their node state. You must press Ctrl+B twice to restore it.